this model. So in a very simple words, travel demand modeling is actually a set of mathematical relationships. Let me change. Welcome in the lecture number 6 about travel demand modeling. Uh, to explain the travel demand modeling or to understand the basic purpose, the terminology is quite clear that we would like to forecast the demand. So that will be a bit far from the reality, but up to 75 to 80%, it will be according to the real scenarios. Why this is called conventional model, or why this is the most commonly used model, or what is basically travel demand forecasting model as. Whenever we talk about TDM, TDM is just a short abbreviation. So in that specific model, through a mathematical relationship, we describe when, why, and how people and goods move with or within or without or within geographic area. That geographic area could be central business district, that could be city, that could be any province, or that could be any country. So there are 4 steps through which we can compute or we can evaluate the travel demand forecasting model, starting from the trip generation, trip distribution, mode choice, and route choice. But the question is why we call it a classic model, or why this model is widely used, world or globally used, because we need less power, we need less computing programming sources, and also we need less data. And this specific model is not that much complicated. Okay. When we talk about the travel demand forecasting model, so we mainly would like to explain about the travel supply, which could be generally represented on different highway networks or roads, or maybe we can consider different transportation modes such as bus, monorails, and commute rails, etc. and etc. So we can select all the 4 modes, and we can use the same model for at least 3 of the mode, such as road, railways, and airport. Okay. Through travel demand modeling, specifically, we would like to detect that what is the relation between person and vehicle, what is the origin and destination, and what type of a route choices he will. As you can see here uh, in the very conventional model, which we call the 4-step model or the trip-based model, which is used to predict the regional travel demand modeling. The first 3 steps, starting from trip generation, trip distribution, model split, are mainly related to the different travel models through which we estimate the demand for travel, while in the 4th one, which we call the traffic assignment or the trip assignment, we would like to uh, calibrate or evaluate the travel supply is the trips are loaded on one or more than one transportation different networks. So we will also talk about the TAZ area, which is called the traffic or transportation analysis zone. That specific zone is actually related to where all those activities such as origin, destination could happen. Okay. So, or we can call that from where we select the origin or destination. As you can see here, starting from the very first type, which we call the trip generation. In the trip generation, we actually would like to evaluate the decision to travel for a specific purpose. That specific purpose could be lunch, could be dinner, could be research activity, could be recreation, could be shopping, etc. So at that specific point, we start our journey. Okay. In that specific slide is you can see here that we would like to analyze or calculate that how much number of trips could be generated in each and every traffic analysis zone. For example, if we take example of Islamabad city, the capital of Pakistan, so we can evaluate or divide the same city in more than 1000 traffic analysis zone. For example, if my location or my accommodation is in the G13 sector and my working station is a blue area and G13 sector is in a traffic analysis zone of 353, while my working location, which is blue area, which is in 750 something. So the transport modeler or the planner, what he will do from the system, he will evaluate that what specific type of a mode is generated or the purpose is generated from traffic analysis zone of TAZ 353 to 750 and so on. Okay. As you can see here, the number of trips that begin from each TAZ. Okay. So trip produces in traffic analysis zone, while again the TAZ means the kind of from the places where those trips are actually produced. Okay. So in the last, you can see here TAZ land use activity. When we talk about the land use, we are referring towards the kind of activities used in that specific traffic analysis zone of 353 or 753. So this is either industrial trip generation or maybe commercial or maybe residential or maybe leisure. When we talk about the second point, socio-economic characteristic, so means the what is the income level of each participant and what is the level of automobile or the vehicle ownership, because if we have the more per capita income, the ownership of the vehicle will be higher. But if the per capita income is less than the global standard, then most of the people will be dependent on the public transportation. The last part is about population. So if we have more people are living in that specific traffic or the transportation analysis zone, so more trips will be generated. So means those 3 points are actually related to production and attraction. Okay. Is you can see here from that specific example. So we call the zone one, for example, home, zone two, work, while zone three, a school. Okay, so zone one, two, three, and so on. You can see here the each trip which is actually produced from home, we call that production, while each trip which is directed towards home, we call that attraction. It's quite simple. For example, if we take example in those two home-based trips, so the first one is basically generated from home to work, while the next one is generated from school to home. Okay, so we have two home-based trip and one non-home-based trip. Non-home means the trip which is not originated or ended on the home. Okay, so if the arrow's direction, if you are not originating from the home, if you are not going to home, so that one we call that non-home based trip. I think it's quite clear. Traction. Okay, one is coming from work to school, while another one is generating from school to home. Uh, the trip generation is the first stage of classic first generation through which we would like to evaluate the aggregate demand model. The trip generation aims are predicting the total number of trips that are attracted in each TAZ or we call that the study area. Okay. So the three different techniques are actually used or methods are used through which we can evaluate the trip generation model. The first one is called the trip rate analysis method. Second one is called classic uh, gross classification method, while the last one is called regression model. Each of these techniques will be discussed in each with example in a different section with example. As you can see here, the trip rate is one of the three methods that are often used to compute or evaluate the trip generation. The trip analysis is based on determining the average travel production or level of travel attraction which is associated with an important trip generated within that specific region. So in a very simple word, we would like to understand that how much trips are based or activities are generated within a single day, within a single week, within a single month. Okay. In the purpose of those trips. So number one, the frequency of those trips. Number second, the purpose. So the purpose could be work, could be leisure, could be shopping, could be recreation. So we would like to understand those two functions from trip rate analysis method. Okay. The next part is about cross classification method. Okay. In the cross classification model, we basically try to construct a table where different rows and columns have different attributes. In each cell in the table shows a predicted number of trips. As I already mentioned in the slide number 1, this is a travel demand prediction or forecasting model. So we would like to predict things before it happens. So that will not be 100% very much near to reality, but of course that will be 75 to 80 or up to the 90% according to these scenarios, because we take all those parameters or indicators through which we can predict different demand model before to plan or design any transportation facility. As you can see here in the trip production model, we would like to see that how much household trips are basically uh, have their own car, which again the second part is what is their income level. Okay, so the income is basically the submodel which actually reflect the different distribution of the household within different income categories such as high, medium, low, and below the low. And auto ownership is again another indicator. Okay, so the through household income, if for example, if someone is having his own house and he might have the ownership of the car of the automobile as well. So that means that he is in a high income category. Okay, so those people will mainly be dependent on their own auto, on their own car. And the trip purpose might be work, might be kind of leisure activities, or we would like to know that. Uh, from the next slide, it will be quite clear that what is the cross classification analysis model as. As you can see here, we would like to draw different different columns in row to understand the car ownership and the household income level. So we have the two X and Y section of that specific graph. And the trip production will be different according to different household. Of course, if their income level is different, if if the number of or the ownership of the car of the vehicle is different, we will have different production household item. So that specific part we can take it from the planning commission, from the income level. Okay, but in the cross classification method, which is completely based on the socio-economic data, which is related to the level of income, per capita income, automobile ownership, and trip classification. Okay, so we usually try to understand that how much number of trips are generated from TAZ, okay, from the transportation analysis zone, which is quite important, because if we did not understand that concept, it will be quite hard to classify that what is the trip generation uh, kind of trips produce in a single day, and what is its function or activity. Its best example is shown in the figure. As you can see here, we have considered the 20 household, and the trip produced per household is again different. And we would like to understand it. What will be the household income of within $100 plus? So we would like to see that. And we also would like to understand that what is the auto ownership per household. So through trip through cross classification method, we would like to know or to evaluate or to draw such type of a graph. Okay, its solution is like that we categorize that in the different incomes level. So as you can see here with zeros, ones, and twos. So we would like to see that how much people contains their own car. So for example, as you can see here in the top figure, so we have the 20 people, they have their own car among almost eight people have their own car among 20 household. So through that process, we would like to understand that, for example, what will be the number of trips as we started from the low, medium, and high income. So if the income is high, they will have more number of autos, and they will again generate more number of trips. Okay. In the cross classification method, as you can see here, we have different household and they have different income level. So we would like to understand that what is their trip in from that specific formula. We would like to see that what is the trip purpose and which zone it is actually moving on, and how much number of household have contain or exist within that house within that specific TAZ zone, and how much number of vehicles they have. So there is a possibility that different TAZ zones will have different level of income people and different number of car ownership as well. So we would like to establish different household grouping category. And again, we would like to see that we would like to evaluate the trip purpose with the grouping activity. So through that method, we can understand the trip rates through grouping technique to multiply the total uh, grouping observed trips and the total observed household on the basis of number of household and grouping divided by total uh, observed trip divided by total household. So the next method is use regression analysis. Regression analysis is a powerful statistical method which allow each and every researcher to examine or to determine different relationship between one or two or different variables of our interest. So through that specific method, we would like to examine the influence of one or more independent or dependent variable. So different methods are used such as linear regression method, non-linear, and multiple regression method. And that example, we would like to understand the zonal trip production per day in any zone of an urban region is given by that specific model. Okay, as you can see here, from zone I means from where the all those trips are originated. So we have four zones. Zone 1, which we denoted with X1, X2, X3, and X4. Okay, so X1 is basically the representation of zonal population, while X2 is the average zonal monthly income, while the third one is about the average vehicle ownership, while the X4 is about that how much adult are having their own household. Okay, while multiplying the regression model, its formula is already mentioned at the top. Y is equal to B naught plus B1, X1, B2, X2, B3. So we have all the value of X1, X2, X3, X4. So we will only analyze the value of beta. So for the very first case, we will imagine any value for the beta. Okay, to kind of so beta is basically the interception between the starting value, and that value could be biased as well. Okay, so we can evaluate that. So the beta naught value could be the biased value as well, because we need a value to start our regression model. As you can see here, we suppose that our beta naught is 150 while B1 is 3.5. So we can evaluate uh, the all the values or the trip generated within those zones, zone 1, zone 2, zone 3, with a simple calculation. So as you can see here, we have different trips per day, okay, in each and every zone. So we have the highest trips within zone 2, which is almost 8,000. Okay. If you have any question, please you can ask in the comment section.